Hello, I'm Matt Fletcher, and this is yet another exciting inspection video. So today we're going to talk about small commercial inspections. And this video I think is about 45 minutes long. So we're going to look at some of the similarities and differences between commercial and residential building inspections. And this is the first of several commercial inspection videos that we plan to do. And we're going to start with a smaller, simpler building and work our way up to more complex buildings in later lessons. All right, so just in case you don't know me, I'm a former high school building trades teacher, and I taught a class where my students and I built a real house, and that's the house behind us that we were working on that year. Let's see. This is a PowerPoint presentation, by the way, converted to a video, so if you want to do the same thing, you can. I really like this method. So this was my classroom here. So we didn't do every single solitary thing to the house. We hired some stuff out, like digging the basement and doing the foundation, and that's what they're doing here. They did the footings, you can see, and then those are the forms for the basement wall sitting on the truck. And as soon as they got those done, we would get in there and start framing. See, we're beginning to frame the house there. We got the floor system on. We're standing up the walls now. We did all the framing and the tie back, and we installed the exterior doors and windows. Concrete guy did our porches. And whenever we hired stuff out, we always went out there and watched, and the contractor would discuss, the trade and how to get in with the kids, and it was a really good program. And on the inside, we helped the electrician, the plumber, and the HVAC guy, and again, he would do a little presentation. We installed all the insulation, and here we're hanging drywall. It was mostly boys, but you can see we have 2 girls in that class there. So, and we did the kitchens and the baths too, and hung all the interior doors and the trim and everything. So it's a pretty extensive program. So there we are. That's the last house we built before they cut the program. So they cut our voc ed and got rid of this program, and that was 21 years ago. And I started doing inspections full-time after that, and then I started training people to do inspections, and now I own Global Inspection School, where we teach home inspection, commercial inspection, and sewer scopes all over the globe for one low price. It's my commercial. globalinspectionschool.com. So here is what we're going to do today. So we're going to look at the similarities and differences to residential homes and commercial buildings, like I said, and some of the similarities we will see are the HVAC system in this building, the electrical and the plumbing. Some of the differences are the break room, restrooms, parking lots, emergency lights, and fire suppression. So I've done hundreds and hundreds of commercial inspections, but I did have some training in this. I took the Carson Dunlop course about 18 years ago, and it was at an ASHI convention, I think in Nashville, so I went there just to take the class. And you can see they gave me a big thick binder. I held it on an angle like that so you can see how thick it is. I think there's 215 pages in my binder, and it was a good class, good instructor, But now, having done several hundred commercial inspections over the past, years, couple decades, I realized that about 90% of what's in this binder and in the class were not really applicable to what the average home inspector turned commercial inspector does, in my opinion, okay? I say this because the class and the binder was really focused on buildings that were hundreds of thousands of square feet, like huge buildings, and you can see in the cover of the binder there that looks like a 40-story skyscraper or whatever. And I've gotten into some pretty big buildings over the years, hundreds of thousands of square feet, and we'll look at some of that later in later lessons. But for the most part, The kind of building that we're going to look at today and somewhat bigger are what the average home inspector is going to deal with. So we're going to start out small and work our way up, like I said. We'll discuss ADA, American with Disabilities Act, ASTM, American Society for Tests and Materials, and property condition assessments. So in commercial work, a lot of it's dominated by engineering companies, and that's because lenders want to have that report stamped or sealed by a PE, a professional engineer, and engineers follow the ASTM standard. All the ones I know follow the ASTM standard for inspecting buildings. So there's ASTM standards for a myriad of things. I think there's one for reading slides on mold tests. You know, when you make the slide when you do an air sample, there's an ASTM standard for that. There's an ASTM standard for facade inspections, which is something we do. And there's one for inspecting a building. So here's today's inspection. So it's about a 3,500 square foot commercial building, which we can see looks, you know, fairly similar to a house here. It's not a 40-story skyscraper. And this was about 80 or 90% of my commercial work over the years. So like a home inspection, we always take a long shot like this, and then we go in and take tighter shots as we start the inspection process. And give things the thumbs up, the thumbs down, give it the finger, like I say. You see something wrong, you point at it and you give it the finger. So let's take a look here. So you can hear me talk about something called SHWEPS. So it's just a goofy acronym I made up that actually is very helpful to me in inspecting. So the first S stands for surfaces, structure. So when I'm, say, on the outside of a building, I'm looking at the surfaces, structure. I just go through my mind, surfaces, structure. I'm looking for peeling paint, cracks in the brick or the block, any anomalies. H is heating and cooling, or HVAC. So if I'm looking at the side of a building, I go, are there any intakes or exhausts for the HVAC system here? So if there are, I look at them. If not, I just skip that and move on to the next item, which is windows, doors, and vents. So are there any windows or doors or intake or exhaust vents on the side of the building, like dryers, clothes dryers, bathroom exhaust fans? E is electric, so that would include plugs, that would include the meter, the weather head, anything electrical. P is plumbing. So in my world, I would include, you know, hose bibs and plumbing, any other kind of plumbing pipes you see on the outside of the building. Gas pipe would fall under plumbing. And then the second S is smoke and fire. So that's, you don't usually have that on the outside of a building, so you skip it and move on to the next item, right? So you're going to hear me talk about SHWEPS, and you'll be sick of SHWEPS by the time this is over with, but if you want to give it a try, give it a try. I formatted my template to SHWEPS for most items, in fact, and I like it. It works pretty well. One of my inventions, my contributions to the inspection world. Okay, so we took a long shot of the front of the building, this commercial building, and then we go in and take our close-up shot. So a light that didn't work, so we put that in the report. Then we hit a pole over here, a metal pole, sort of a stanchion pole. So we do it like we would inspect a stanchion pole in a basement, right? Connection at the top, make sure it's secure. Then you look at the bottom to see if it's rusted out, because they rust out over many decades. Here in Detroit, it takes about 80 or 90 years for one of those to rust out. So that was about it on the front, not much going on there. So then we move to the left side of the building where there's a little parking lot area. There's my old inspection rig from a long time ago. I did this inspection, I think, around 2006, but I updated some of the numbers. We're going to do some cost estimating, and I updated the numbers so that they would seem more relevant today in 2026. We're doing this. So there's a sign. So this is a little different from a residence, right? So surface of structure, we're going to look at the, peeling paint on this block, if there's any cracks, things like that. H is heating and cooling. There's no heating and cooling on this side. It's all on the roof. W is windows, doors, and vents. So no windows or doors right here, but there's some down. There's a vent up there. See that vent? E is electric, so we'll check the lights. P is plumbing, so if there's a gas meter or something on here, we'll take a look at that. And then the second S, like I said, is smoke and fire. So, usually have that on the exterior of the building, so we just skip over it. All right, moving right along here. Inspect that sign attachment. So signs can fall off of buildings and hurt and kill people and damage vehicles in the parking lot where it's parked under it. So that is part of the protocol. You inspect the signs on commercial buildings. And it doesn't matter if it's on the side of the building, you inspect it for attachment to the building. If it's out in the yard, toward the street and it's lighted up, you also inspect that. You inspect to make sure the lighting's working on it. If it's got a plug, it's GFI protected, things like that. So this is the other end of that same side of the building. So like I said, SWEP, surface and structure, we're looking for cracks and peeling paint. H, there's no HVAC on this side. E is electric, so we got electric light, we got a meter, and we got a masthead. W is windows, doors, and vents, so we got windows and doors on this side. So we check all those items, and there's our lead paint warning. So this had peeling paint, so we do a lead paint warning on there. There were no cracks on this side of the building. Oh, there's one, I lied. This is above the lintel. So see how that lintel is wavy? You see that a lot in these big commercial buildings. We have these big lintels. And I've read a lot on this subject, and most people agree that it's thermal expansion where the sun hits it and the metal expands and it warps like that. And then you got this gap up above here. So that's a defect for the report that needs to be filled in with mortar or whatever. So if you're not familiar with lentils, I made a little graphic here. So all the graphics in this presentation I made with my software. And you are welcome to stop the video and do a screen print and download them and use it if you want for your inspection clip art. So this lintel, you can see this one's T-shaped on the bottom, and it carries the load. It goes over the window opening, and it carries the load of the brick across there. And this is the part that you have trouble with. It rusts out, and it sometimes warps like we just saw. If it's just warped, I don't put that in the report as a defect, but where you hit that crack and then they're rusting out, those are defects. The warps, no one's going to fix the warps, so I don't see the point. So I call this giving it the finger. So the light over the door didn't work, so I gave it the finger, and it goes in the report as a defect. Giving it the finger. So that's it's got a globe over it, and we don't take globes off to test with a hot stick. If I could have gotten my hot stick or voltage detector in there, I would have used that to see if it was hot or not, but it wasn't. So, and that's the condensing line going up to the air conditioning unit on the roof, I believe. So the masthead had some bare connectors on there, so I give it the finger like that to show where the problem is. Then I go in closer for a shot like that to show the customer exactly what's wrong. So this is kind of a parking lot and an alley at the same time. So there's a street down here, residential street, and then I'm standing at the other end at the other residential street. And this is an alley, but this is the parking area for this building here. It had a little parking area that kind of set up as common here in Detroit. And let's take a look. So this is the parking area over here. This is the alley on the right. So you're looking for cracks, potholes, uneven surfaces, just like on a driveway at a house, right? No difference there. There may be writing. There's not in this lot, but there may be writing in parking lots. So parking stripes for parking spaces, directional arrows, I might say one way. Parking space lines, like I said, handicap markings for spaces. Parking lots should also have parking bumpers or blocks, and we don't have any here. See this? That's to protect the building from the cars in the lot. We've all seen news stories where someone drove through the side of a Walmart, so that's what those are for. Bollards as well. I don't think we have any bollards, which are metal poles sticking out of the ground that protect the building. A lot of times they're filled with concrete. So there's a bad spot in the concrete. You write it up just like you would in a residence. Not a big difference. So if you're going to get into commercial inspections, I recommend you buy a measuring wheel like I'm holding there. And they're about $35 at Home Depot. And you will need it to measure parking lots in case you have to give cost to cure estimates, which are more or less expected a lot more in commercial property inspections. And you'll need it for parking lots as well as flat roofs. So that's why we had that picture in there. Speaking of roofs, let's go on this roof. So this is why I picked this building. It had a pitched roof in the front. It's not that big, and it's got a flat roof on the back. So you can see this flat roof is kind of in tough shape with this long shot. We can see some sinkholes, and they're dark, meaning there's like organic material in there because water's there a lot of the time, sunken in. So we're going to Schweppes the roof. Okay. I believe this is a torch down roof. So what is a torch down roof? So commercial roofs, commercial flat roofs are different than homes, and this is probably the biggest difference I can think of. So a torch down roof is a single or multiply rolled membrane made of modified bitumen that is heat welded to the roof using a propane torch. Some of the key features are there are 2 or 3 layers. The seams are melted together with a torch. It's faster installation than what they call a built-up roof, which is pretty similar to this look of a roof. It's hard to tell them apart, especially when they've been silver coated several times. They have good flexibility and waterproofing, but are old technology and found on older buildings. I've never seen a torch down or built-up roof put on a new building. I guess it's possible, but all the new ones I see are either TPO or EPDM. We see these roofs on maybe balconies here in the Detroit area, the torch downs, and unlike commercial buildings like this one is. And there's why we call it a torch down. He uses a torch to melt the seams together. They were not joking when they call it torch down. So here's another graphic I made, and you can screen print this if you want and use it. You're welcome to do so. So starting at the top, you have the top membrane, the top surface. Number 2 is the bitumen underlay. Then there's a protection board, rigid insulation, which is a big difference between homes and commercial buildings. So the insulation is outside the sheathing, right? It's on top of the sheathing in this case. Then you have a vapor control layer, the roof deck, and the joists. We have wooden joists in this case, but a lot of times they'll be metal. And then there's an interior ceiling. So that's generally the makeup of a flat roof. There's some differences here and there in different styles, but that's basically it. This is a picture of a car dealership we did. We did some draw inspections, and this is, if you're from the area, this dealership was on Hall Road in Macomb County. So you can see it had, the sheathing is corrugated metal, and then there's 2 layers of rigid insulation over top of that. And they connect it down with big metal screws and that go into that sheathing. And they've got a big washer on them too to hold the insulation down. So I mentioned silver coating before. So on those old technology roofs like torch downs and built up roofs, they will silver coat them like this to protect them. So that's not just a paint, it's a waterproofing product. So Here in the Detroit area, there's one called Durabright, and Henry makes it, and it's a thick, it's like a paint, but when these roofs get old, they crack. They call it alligation, and that product is made to fill those cracks in to waterproof it, and then it's silver to reflect the sun and the heat off the building. And there's what that product looks like. And I put this picture in there because a lot of times you'll see these buckets still sitting on the roof after they're done silver coating it or sealing it. And if you see anything like that up there, write it up as a defect, because high winds can blow those off of flat roofs and hit somebody on the street below or their car and cause damage. So anything that's not secure on top of that flat roof, you write up as a defect. All right, so here, back to our roof on our inspection today. So this is why I picked this building. It had a pitched roof, dimensional shingles that we're all familiar with, and then it had what I believe is a torch down roof. And see this huge puddle here? See how dark it is? When they're dark like that, that means water stands in there for a long time because organic material has started growing in there. And the rule is 48 hours on a flat roof. The water's supposed to evaporate off the roof within 48 hours, otherwise it's a problem. Well, I write up all ponding water as a problem. I've never seen an inspector stay up there 48 hours to see if it evaporates or not. So anytime I see ponding water in a building, I write it up and say, hey, look, it's not draining completely. And you could develop a leak later on because of this. Excessive wrinkles. This is an old roof, and when they get old, they wrinkle up like that. Another indication of age in this type of roof. See this hole here? And there's a bunch of schmutz in there, so that was probably algae and stuff growing in this deep hole. And there's probably rot under there, right? So you don't step in these holes when you're doing these roof inspections, because you could fall through, walk around them. But that other hole was full of water, right, that we just looked at, and this one's dry. Why do you think that is? So it could have been shallower, maybe that's the reason, or maybe there's a hole in the roof and it's dripped through into the building, right? So this is surface of structure, this part of the roof, this part of the inspection. So surface of structure, see big sinkholes over here. This whole area is dark. This looks like a problem area over here to me. Give it the finger. So wherever I see something I want to make a comment about in my report, I give it the finger like that. So another deep hole. Again, don't step in those holes. You could fall through if there's rot in there, and there probably is rot. If it's a metal corrugated roof, then it could be rusted out. The dimensional shingles look pretty good. I think they were newer than the rest of the roof, so we don't spend a lot of time on that. So that was surface of structure. So now we're done with that surface of structure. So now we go to heating and cooling on the roof, which we do have heating and cooling on this roof components. So we got a condensing unit, and it was a 1989, so that's old as heck, and we put that in the report as well past its expected useful life. And the data plate there, it's called the data plate. Still on H, there's a chimney which the furnace was vented into. There's no liner, no rain cap, no spark arrestor. That's a defect for the report. This is another graphic I made of a flat roof. So roofs do have windows and doors. Okay, so if you think Schweppes is dumb, I'm here to correct you. So the windows would be skylights. Like I said, this is just a checklist, a mental checklist that I go through. So the doors are the scuttle hole to get through there. And then there's vents. See the vents here on the side? And then there's vent stacks here for like restrooms and break rooms and whatever. So again, I made that. You can download it if you want. Just pause the video and do a screen print if you don't know how. So yeah, windows, doors, and vents. This is an actual vent on the roof that we're inspecting today, so that's what that looked like. No problems there. He's electric, no GFI, so we give it the finger and write it up in the report. That's those same connectors where I took pictures from the ground, but I take it from the backside as well. That's E's electric. P is plumbing, so we got soil pipes, more soil pipes. They looked okay, no issues there. And we got a scupper hole. In case you don't know what a scupper hole is, it's a drain on a roof, and it goes down through the center, you know, in the middle of the building, not on the outside, and it carries the water into the sanitary system or storm drain, whichever. Old buildings will be made of cast iron, the drains, and new ones will be PVC. All right, so we're done with the outside. We did the roof and all 4 exterior walls. I didn't include all the pictures because this would be too long, so we're just going to look at some of the features that make this a commercial building, show the differences. So we Schweppes the lobby, right? Service the structure, H is heat, so on and so forth. So this is my template page. I call this common spaces. It got cut off there a little bit on the end, but this is common spaces for commercial template. So surface is structure, H is heat. You're supposed to have heat sources in different areas of the building. Windows, doors, and vents. E is electrical, P is plumbing, the second S is smoke and fire suppression. So I have my template arranged in that manner too. So, and it works for me. If you want to try it out, you can, but you know, I've been doing it this way for probably 15 years and I think it works very well. So surface of structure, we got some water damage. Remember, we saw that roof was bad, looking pretty scary. So we have some water infiltration into the building. Take a moisture reading to see if it's wet at the time of inspection. We can see that's pretty dry. It's bone dry, it's 0. When I train people to do inspections, you know, you have to look above the drop ceiling. I know a lot of organizations say you don't have to do that. That's one of the dumbest things I've ever heard, in my opinion. You find a lot of trouble above the ceiling. So here, you know, we saw some additional watermarks. You know, you can see the watermarks on the ceiling tiles, and you can see wire. There's just Romex wire laying all over the top of this ceiling grid, and it's metal, and you got a splice right there, junction with no junction box on it. So, like I said, when I train people to do any kind of inspection, you try to look above the drop ceiling. If they're stuck, then you don't have to force them. You don't have to break them. You know, no one expects you to do that, but it's a very good idea to look above that ceiling, and I require it in my training. H is heating, so we got some heat vents in the floor. When they're in the floor like that and you can just pull them out and look in there, we always do here in Michigan. So this building's on a slab, if I didn't mention that. So when you have ductwork in a slab, it can rust out and fill up with water. You have all kinds of issues with that, which is why I think most contractors don't do that anymore. It's all in the ceiling now. So let's see. So I pulled that cap off, and here's what we saw. That register cover, I should say, not cap. So it was all rusted out in there. That's why they abandoned those. They weren't using those anymore. They had moved the ductwork to the ceiling. We'll see later. There's another graphic I made. If you want to print it, download it, that's fine. But it shows the water in there. See that? And I've pulled covers off there and looked down in ductwork and seen standing water in there. It happens pretty often. So surface of structure would be the ceiling and the walls and the floor in here. Electric would be the plugs on the wall there. Windows, doors, and vents. We got a big, huge window here that needs to be inspected, so we do all that. Pretty much like a living space in a house. Not a big difference. Here's a difference. So doors on commercial buildings swing outward, and they have low thresholds. So what happens, the threshold is a ½ inch or less, and the door swings out, so the building settles over time. and the sidewalk doesn't so much. So because the door swings out, it will drag on that exterior sidewalk a lot. That's a common defect in commercial buildings. So emergency lights is another difference. So you'll have emergency lights like this in common areas, hallways and things. And they're just like smoke detectors, guys. They're hardwired with battery backups, and you push that button to see if the light comes on or not. And if the light doesn't come on, it's a defect for your report, of course. Lighted exit lights are required in commercial buildings. Again, that door swung out. You can see the hinge on the inside. Plumbing in commercial buildings. So you'll run into drinking fountains in commercial buildings, and that's part of your inspection. So there's regulations regarding drinking fountains. The top surface no more than 36 inches off the floor. You have to have an area here in the front where a wheelchair can get in there and turn around. It's usually about 60 inches. And you got to have the big push bar, not a handle, big push bar, less than 5 pounds of pressure to activate the water. So I made that graphic as well. You can download that if you want. I have software that I make this with. So check that drinking fountain. I always take a big long drink of water because I don't get enough, and then I shoot the water with my laser thermometer to show that the cooling device was working. Still on plumbing, there's a, just like a house, comes out of the floor, goes through the meter, the pipe, and then comes up. There was an open pipe underneath here, probably for a sprinkler system that was never installed or abandoned or whatever. So I gave it the finger and put it in the report, unknown pipe sticking out of the floor. And then I say, might be for a sprinkler system. So here we are standing in a common area in this building, and we can see 1, 2, 3, 4 doors. So now we're going to go office by office and do our Schweppes procedure for inspecting the office. So what you do is you walk up to the door, take a picture of whatever's on the door, if there's a sign like that or a room number or whatever. You take that picture, then you go inside and do my Schweppes thing, run through my checklist, inspect everything, and let's see what that looks like. So we go in, we take the picture, we go inside. You could, again, that's home inspector sign language, so you can hold the finger up, say office 1 like that, office 2, office 3, office 4. Besides taking a picture on the door. Sometimes there's no signs on the door, so I do that to show a break between them. So office 1, surface of structure, got some more water damage, ease electric, you got some water dripping into the light fixture, so that's an issue. Check for heat. Always use a laser thermometer. I check for actually working heat in every room, not just that there's a vent there. I make sure there's air coming out of it. Or if it's a radiator, I make sure it's getting hot, and I document that way. I don't take a picture of every single vent like that, checking it with the laser thermometer, but I do check for it in every room. I just do 1 or 2 pictures like this to document that I tested it. So that's a good idea to do. So that's H heat. What do we skip? Electric, windows, doors, and vents. So this one had a window. Oh, there it is. East electric. They're out of order. P is plumbing. Gas meter goes in plumbing section in our reports. All the gas pipe. So that's it. There was no smoke and fire in that room, so we skip that. And we go to the next office, facilities manager, and we just do the same thing over and over again, so you get the idea, so we don't have to go through every office. So let's look at the break room. So break rooms are pretty much like kitchens. There's one difference. Break room. Run the water, check for leaks. I found a leak, so I give it the finger. Gonna put that in the report. Then you check underneath, see if you got any leaking going on. It's all good under there. Here's the difference. You have fire extinguishers, throughout the building, but especially you'll see them in break room areas and any like work areas, like a warehouse or whatever. So you take a picture like that. There's an expiration tag on them, and there's months and years on there, so they punch out the month and the year that it expires, and you can take a picture like that to see if it's expired, so your customer will have that. Check the smoke detectors, of course. That's an old one, right? So we put old ones in the report as a defect. If they don't look new, I put them in there as a defect. So they appear to be old. They have a shelf life of usually about 10 years. And now you can't change the batteries in them. They have a permanent battery, so when the batteries go dead, you have to take it down, throw it away, and buy a new one. And that's by design. So you always have a new smoke detector and not the old ones. Let's check a restroom, handicap restroom. It says doors 36 inches. ADA stands for Americans with Disabilities Act. So we put a disclaimer in our report that we're not there to do a ADA compliance inspection, but I will refer to it if I need to for whatever reason. So, but you can download the ADA requirements for restrooms online in a PDF, and I recommend you do that and go through them and take them with you when you go do a commercial inspection, just so you have them, so you get everything memorized. So inside we got some nice grab bars, which were bolted, to the wall nicely, not just duct tape to the wall or drywall screws. Drywall screws are actually great. People always make fun of them, but those things are great. They're virtually indestructible, and they hold a lot of weight. Anyway, run the water, check for leaks in the bathroom. Flush the toilet, check for leaks. It's just like a house. Crummy window, that goes in the report. Electric's good. So here's the difference. So you have to have your plumbing underneath insulated with these. They're kind of a bumper pad and insulation. So if someone in a wheelchair might be paralyzed, right? And if they roll up to here to wash their hands, this P-trap does get pretty hot when you run just hot water. And then of course the hot side will get very hot, the valve. And then they could skin their leg on anything else under there. So, and like I said, they might be paralyzed and they might have other health issues. So, if they burn their leg or whatever, they could get an infection and go septic, and it could actually kill them. So that's why they have these safeguards like this. So that's a big difference. You need to check for that. Take a picture like that when you do a commercial inspection. So here's the sink. Let me stretch this out, make it bigger so I can read it. So this is for ADA compliance. So you have to have a certain kind of faucet, that gear shift lever type device, not little handles anymore. The mirror can be a maximum of 40 inches off the floor. You gotta have a turning radius in front. And the sink here, it says 34 inches to the top of the sink. I made these two, so you're welcome to use them if you want. So this is a good one. You got your 60-inch turning radius here. That's 5 feet, right? You got a 36-inch wide door. Here they got 60 inches minimum to the left and the right of the door. That's to make this space that big, right? And you got your handicap ADA compliant sink with the insulation underneath. You got your grab bars around the toilet. So we're looking pretty good here. Good looking ADA restroom. So there was a warehouse on this building too, so let's Schweppes the warehouse. I told you you'd be sick of Schweppes by the end of this. So surface of structure, heat, windows, doors, and vents, E's electric, P is plumbing, S is smoke and fire. Surface of structure. So we had a crack going from the top of this wall down to the bottom, and it was pretty consistent from top to bottom too. So I don't know if it was the vibration of this big door going up and down all those years, or maybe a car hit it in the parking lot because there's no parking curbs out there, right? No blocks. So that we give the finger, right? See my finger? And we put in the report as a defect. H is heat. So this doesn't meet code around these parts anymore. So this furnace was in the warehouse where you could pull a car in. So I believe that qualifies as a garage. So you could pull a car in there and leave it running. And then your furnace, which is your heat source for this area, would suck the carbon monoxide in and blow it through the rest of the building. So this would have to be sectioned off in new construction, but back when this was built in the 50s, I believe, this was acceptable. So, and there's the ductwork going through the ceiling. Remember, it was in the floor and they abandoned it, and now you can see where it goes to the ceiling here. Windows, doors, and vents. Those old aluminum windows, we write those up as old and a sweat issue. They sweat like crazy. Still on windows, doors, and vents. Here's where that big crack was over there, right in there. So in here, we run the door up and down, check the safety sensors, make sure the spring's not broken. There's sometimes, a lot of times, 2 springs on the door. One can be broken and the other one still works, then it'll raise the door up and down. So you gotta check both of those, just like in a house. E's electric, nice GFI plug. P is plumbing, run the water, check for leaks. Always take a picture of that water running too. You don't mess with water. I should have said that on the roof. If you ever get sued as a home inspector over one of your inspections, there's about an 80% chance it's going to be over a water issue. A home inspector spells lawsuit W-A-T-E-R. Okay, water. It's all about the water. There's that furnace. Let's take a look closer. Look how rusted that heat exchanger is. So this is a really old furnace. You don't even see these anymore where you can actually see into the heat exchanger. You don't see that anymore in furnaces. It's an old furnace. 1991 on the data plate. So that goes in the report as a defect. I put well past expected useful life, defective. I'd say working fine today, but is well past. And we do a carbon monoxide test on them too and take a picture of the reading so that you have that for proof that you did it. But this goes in the report as a defect at that age. If we're a couple years past, marginal, and then all the same verbiage, past expected useful life, things like that. Water heater's 97, that's a defect, well past. Electric service, so this is a was that a Wadsworth? So I recommended a service change here because first of all it was full, and when you renovate a building, which they were going to do, the first thing you need is more circuits. So around here you could get a service change done with a bigger box. This is 100 amp. They might want to go to 200, which involves more issues. But you can get a 30 circuit 100 amp box too, and you'll have more circuits. But around here, 2,000 to 3,500, probably around 3,000, I would say, for a service change where I live. And if you search on, what did I say that was, Wadsworth or Westinghouse? See, is it close? There it is, Wadsworth. So if you Google Wadsworth electric panels and the word fires, you'll find information on that. But you know what? I've come to the conclusion that that's true of all these old panels. They've all been labeled on one website or another as a fire hazard. So it doesn't matter what brand it is. If it's that old, this is probably from the 50s, it's going to be written up. And you can find information about them causing fires online, along with FTPs, Federal Pacific panels. There's a shot of the inside. Plus, you can't find new breakers for them, replacement breakers. So let's talk about some cost estimating here on this project. So like I said, cost estimates are far more expected in commercial properties than in residential. In fact, when you do your commercial training, when they're done to ASTM standards, they have a special phrase for it. It's called replacement reserve table, instead of cost to cure. So ASTM calls it replacement reserve table. So the bank wants to know that information. I got the binder right here. Still got my binder. There's my Carson Dunlop binder. And we're going to talk about the RS Means catalog here too. This is my RS Means catalog. There it is, RS Means. So I don't use either one of those books I just showed you anymore. I don't think I've ever used the Carson Dunlop book. Maybe once or twice for something, but not much. So this RS Means catalog, in my opinion, again, everything in this video is my opinion. This catalog is way too complicated for what we do. I don't use it anymore. You can see it's old 2003. I've got newer ones, and I've got a different brand called National Repair and Remodeling Estimating Guide, and I don't use any of them. You know what I do now? I belong to Facebook groups, and when I do inspections around Detroit, all my Facebook groups are guys around Detroit. So I've got a roofing group, windows and siding, concrete, gutters, whatever it is. And I take my pictures and measurements and I'll put them on Facebook and I'll say, hey, how much do you think it would cost to put, 21 windows in this building or whatever it is, or roof, here's the measurements, what do you think? And guys will throw out numbers. And if they do, I'll say, I'll tell my customer, hey, this guy, here's his name, gave me this number as a ballpark estimate. If you want to get a more accurate price, you need to have him come out. There's nothing wrong with that. I don't know these guys from a hole in the ground. I always tell the customer that. I don't know these guys from a hole in the ground. This is what I met this guy on Facebook. But this is a very accurate way of doing this. Far more accurate than this book. And then they have software too. So I keep mentioning the book, but they have software which may be easier to use. But this book is a nightmare to use. You have to take a class just to use this book. So I don't use it. So let's look at my report. Like I said, ASTM calls a commercial inspection a property condition assessment. They don't even use the word inspection, which I've always thought was very smart of ASTM, I think it's run by engineers. They're intelligent people, so they don't even use the word inspection. So you're there to assess the condition of the property. You're not code enforcement, all right? Here in Michigan, I am a licensed builder, and we're required to have the code book in our office to maintain our license. But I rarely go into code stuff with people, and it's never come back to haunt me. Like some of the stuff I see on these chat boards on Facebook where guys tried to cite code to somebody and they didn't know what they were talking about. So I steer clear of that wherever possible. Let's see here. Let me look at my notes in this card here. So we're going to look at the cost to cure numbers here, or that reserve table that ASTM calls it. So this is PalmTech. If I didn't mention that, my software is PalmTech. It's an ancient version of PalmTech. It's PalmTech 6. So PalmTech has a final comment section. So mine all read this way. Your inspection is not over. 4 exclamation points. Now that you have your written report, we strongly recommend the buyers contact qualified contractor to review any and all marginal or defective items listed in this report, because before the buyers purchase this property, inspectors are generalists and not necessarily experts in any single area, such as electrical, attic venting, leaking basements, blah, blah, blah. A qualified contractor may find additional issues or may have different opinions. Any written or spoken cost estimates are only ballpark estimates or guesses. Please call 3 contractors specializing in that area for specific areas for further evaluation and more accurate quotes. So that's my disclaimer. And so the cost estimate area, so because not all reports have a cost estimate area, right? This one does. So we got 2 disclaimers basically saying the same thing, okay? Only ballpark numbers, all that sort of thing. So let's look at it here. I thought I made this smaller down my little window there so I could see all the numbers, but so forced air conditioning, electrical. So, and I put a little verbiage in there as to why I think it would cost or why it needs to be replaced. So I will say that. So I always double the number. So my high number is double my low number. And I brought this up when I took that Carson Dunlop class, and I remember the instructor said, yeah, that's fine. That's legitimate. That's an acceptable way to do it. So I've always done it that way. So on the high end, this air conditioning unit would be $6,000. On the low end, $3,000. The electrical service, I've got $2,000 to $3,500. The furnace, I've got $3,500 to $7,000. You can't see it, but there's a 7 under there. So it's all pretty much always double. And when you do that, you'll always be right as far as your cost estimates go. Plumbing for that water heater, that old water heater, $900 to $1,500, and that's what they cost around here installed. So the roof, oh boy, I thought I made that smaller here too. So the roof was $24,000 to, so whatever $24,000 double is, which would be 48. So that's what that would come out to. And I give, let's look closer at the roof. So I broke it out for different types here: modified bitumen roof, EPDM, TPO, PVC. So different roofs cost different things, right? Different amounts. So when you have this $3 per square foot might be an outlier. So you can feel free to throw those out of your sample. So you want to go with the mode, right? The mean, the median, and the mode. So the mode in a group of numbers is the number that shows up the most often. So if most of your guys are saying, hey, I'll do that for $9 a square foot, that's probably what it's going to be. And it's per square foot. It's not square yard or square like siding, which is a 10 by 10 area, or shingled roofing. You know, a square is 100 square feet. This is a square foot, okay? A square foot. And I didn't block my number in this one so you can see. Yeah, this is a very expensive repair for this building. There may be rot in the roof sheathing. We strongly recommend you get estimates. So that's to protect yourself. What people will do is they take these numbers and they go back and try and renegotiate the price. So if anything, you want to be too high. You don't want to be too low. If anything, you want to be too high. But ideally, you want the actual cost to be between these two numbers. Literally double. The high end's double the low end. And like I said, that I've done that way. I've done it that way for years and years, probably 20 years I've been doing that. More on the cost estimate continued. Is there anything new here? I think we covered everything so far. Yeah, replacement on the roof, 31.8 to 58.9. All right, let's review. So commercial buildings have a lot of times have flat roofs, and often those flat roofs are old and damaged. The biggest issues are draining and ponding, rot, parking lots. If it has lighting, that's part of your inspection. The parking blocks or curbs should be inspected, whether they're there or not. Sometimes they're damaged. Check for potholes, just like you would in a driveway. Marked parking, like handicap spaces. Restrooms, if the building serves the public, you may have to have a handicap accessible bathroom. Break rooms are inspected much like kitchens and dining areas. They have fire extinguishers though. Emergency lighting is part of the electrical inspection, so make sure you check that emergency lighting. Remember, you got to push that button and make them come on. Drinking fountains are part of the plumbing inspection, so if you see any drinking fountains in the building, don't just walk past them, make sure you inspect them. And again, the fire extinguishers, wherever they are, whether they're in the break room or just in the common area, sometimes they'll be in a hallway, so make sure you check those. All right, let's see what else. Roof. So the HVAC and the electrical was pretty much like a house in this building, right? So this was not a tough one to do, which is why I picked it. We'll get into some bigger stuff later. So this is the last slide, guys. The road to success is always under construction. That was one of our students, and I love that shirt. He came in there wearing that one day. I was like, oh, that is so awesome. Let me take that picture. That's my favorite picture. I've taken about 1 million photographs of me teaching construction, inspections, and construction projects we've done. So I've taken about 1 million pictures, and that's my favorite because it's true. And you should always up your skills, always be learning. Don't become complacent and think you know everything, and then something new comes up that you did not know. So anyway, this is just to sum it up here. This is the first in a set of educational inspection videos I plan on making here. Future lesson plans are more on commercial buildings, bigger and larger buildings. I'm going to do one on why every home inspector should also be a real estate investor. So if you're not into real estate investing, you should get into that, because you have all the contacts, you have all the skills. You're crazy if you don't do that. It's worked out pretty well for me over the years. I've got another lesson just on commercial parking lots that we'll go over. See what to look for there. And a separate lesson just on flat roofs, and a sewer scope lesson. So big plans for the future. Like and subscribe, make a comment. Like to hear from people. If you have any requests for future videos, I'll certainly take a look at that. I am Matt Fletcher. Thank you for watching.